Okay.
Over to you.
Okay. Thank you very much, and so thank you everybody for hosting us and for giving us the opportunity to present what model-based product line engineering is, and especially today. So we will focus on this topic because it was also part of our book release that let's say happened to be around 1 month ago, roughly 1 month and a half ago. And as Jessica mentioned, so I'm with Tim, and this is the agenda for today. So we'll start. The agenda will follow the structure of the book, and we have an introduction of the topic, and then the motivation, because as every engineering change to be performed within an organization, you always have to start with the motivation. Why I'm doing it. And then after you do, you have the motivation set up. Then you need to, of course, work on the foundation. So what do you need to know before we start implementing it? And then when you got the, let's say, the basic skills and maybe a bit more advanced skills, then you have to start. You can start implementing it. And once you have tried with one or two projects, then if everything is successful and as expected, and after some adjustments are made, you can go into the adoption. And this applies to any type of system engineering discipline. And today we will apply this to model-based product line engineering. And finally, we will, we thought when we started the book that there's no, I would say, a book that would make sense, especially when you talk about return of experience, adoption. So it needs to have, must have practical cases. And that's why we have also industrial cases of companies that decided to contribute and write a book together with us. And these are, you will see later, some companies, and I will showcase today a couple of them. Good. So let's start. Introduction. We skip it because we've been already presented. So I'm Marco Forlingeri from PTC and also from INCOSE Product Line Engineering Working Group. For some of you, maybe I'm already say not too old acquaintance because I was the assistant director for the Asia and Oceania sector of INCOSE. But in December last year, I relocated from Singapore to Europe, and that's why now I'm kind of it's a stop this role because geographically I'm not there anymore. And then we have Tim, as was presented. Tim, maybe you want to spend a couple of words about yourself.
Yeah, hello, I'm
And
Tim. So, yeah, also thank you from my side for the invitation and the opportunity to present MBPLE here at your chapter. Yeah, Jess already introduced me very well. Maybe another note is that, well, I was lucky enough to join the SysML version 1 team more than, wow, almost 25 years ago. Time flies by. We were only a very small team of 15 people, uh, and I learned a lot there. And since then, I have been active in the OMG, the object management group, and have helped with many other standards and the certification programs. But in particular, I also joined then from the early beginning the SysML v2 team more than 10 years ago, also a very long time. But now it's almost done. I'm co-chairing the task force that finalized the SysML v2, and it will be officially be there in 1 or 2 months. Uh, so yeah, that's uh, about me. And I hand over back to Marco.
thank you, Tim. Thank you very much. Today we want to start with the motivation, and I would say a sentence that will describe, at least for us, the best, I would say, in the best way possible, the motivation of why to do product line engineering, why to start adopting model-based product line engineering, is that no organization builds just one. So if you think about common today's enterprises, and especially all those enterprises that survived for many years, you can see that they have a commonality, that is that they build more than one product. And if you, even at the large defense contractors, usually they build more than one product along the years, and even if these products, they look like there's no reusability for several reasons, constraints, at the end there is reusability if you really do it right and so strategically. So let's say no organization builds just one, means also that if you build just one, it means that you are really basically building a commodity. So, or you will be soon out of market, soon in bankruptcy. So that's basically, there are maybe few examples, very few examples that you can count on the fingers of your hands in the world of organizations, specific niche organizations that may build just one product. But in general, this is the key motivation. And this is also reflected in what in different industries, so defense, aviation, so vacuum cleaners and trains and automotive companies, and so excavation companies, so industrial companies, industrial equipment companies. And by the way, all these companies that we show are companies somehow that either me or team work with. So that's why there are many of them, plenty of them, that you can see all of them built more than once, and you can see reusability, at least from the pictures about those products, at least from the way they look like. Now, this was for us the key motivation, and that's why we decided to write a book. And as I mentioned, there was not a book about product line engineering. Actually, there is one book about product line engineering written by Paul Clements and Linda Northrop, and this was done in the early 2000s, so over, I think, something like 25 years ago, by the University of Carnegie Mellon. And that's why I think after 25 years, probably, it was basically software oriented mainly. And this book, it's system oriented, let's say, more system engineering oriented. And also because of the connection that team and I have with INCOSE and with the systems engineering for our careers. And yeah, so these are the companies that wrote the book with us and that implemented model-based product line engineering in their own, of course, following some common patterns that we'll talk about. So Airbus, MBDA, Raytheon, so RTX, Thales, and not only those big aviation, aerospace, defense company, but also Belimo, that's HVAC business providers. So basically, they provide a solution, HVAC solution worldwide for industrial buildings, like airports or factories or very, very huge building, conference venues. And so this shows that somehow product engineering is something that you can apply across products, across industries. Now, we didn't write the book just team and myself. So it was also written by Hugo Guillermo, that from Airbus, and Hugo Guillermo is leading product line engineering at Airbus, together with design exploration and multi-dimensional optimization. And he was also the founder of the product line engineering working group at INCOSE. And as I said, how we met, probably all three of us, is through system engineering passion and through the INCOSE activities. We decided to come together and to share our experience, share our return of experience with you and with everybody that is interested about it. So this was just an introduction. So we continue with the motivation. So let's have a look at the real motivation. Okay, we already know now that no organization built just one. But okay, and those organizations, let's say 99.9% of the organizations in the world that build more than one. So how do they reuse usually? So which type of reuse practices they apply? So when I was working at Airbus, I led model-based product line engineering at Airbus, and there usually you think that at Airbus you may use complex example to describe what the system is and what Reuse is what reuse across systems is, but you need to understand that at Airbus you don't have only aircraft engineers, but you also have marketing, sales, procurement, process people, tools people. So those that have never seen an airplane in the final assembly line. So that's why, and they don't know the airplane terminology. And even with the engineers that be aircraft engineers, sometimes if you have a in the first discussion to explain a problem, to explain a discipline, if you use their own example, you may have a blocker in the discussion because they will just focus on the technical details instead of the methodology, the approach that you are presenting. So that's why we decided to use Disney. You may be surprised now why Disney, and you will see now why we choose Disney to explain what reuse is and why companies reuse. So you can see here two different products, let's say two different systems, right? And they have been built for two different types of stakeholders. Okay, there is a 10 years gap between these two stakeholders. And even if the setting is completely different, one is about the adventures of Winnie the Pooh, and the other one is the Jungle Book. You can see the reusability in it. You can see that there is a reuse of behaviors of animated scene, even if the background change a little bit, the colors, the characters, you can see the reuse in it. And in every details, not just in the in one details of the background or but in the full animation. Okay. Now you may think that this is just one example, random example, and maybe a reuse that happened once. But if you look across all the Disney's movies, and most of them, especially those before Pixar acquisition, you can see that there is a high reusability across movies. And these videos, I could run it for 20 minutes, so we don't want to spend 20 minutes on it. You can find it on YouTube, writing reuse Disney. And but the idea, I think, at this point should be clear, right? That Disney implemented a reuse approach from one movie to another along the years. So now the question is, why did they do that? Well, they do that because they were forced to do that. So imagine if you have to develop the sketches of some drawings of and then you need to animate them. You need to test the animations, and the same thing you can apply, let's say, to your system, right? So imagine if to develop a system each and every time and test all the artifacts that you need to build your specific systems. So then this is requiring a huge amount of time. And in order to come up with a movie every year or every 2 years, so they have to reuse. They were forced to reuse. But how did they do that? How did they reuse? Well, basically, they probably use a clone and own approach. So what is a clone and own approach? Well, clone and own approach is basically a type of copy-paste approach. Copy-paste in engineering development is called clone and own, and also in software engineering. So the idea is that you have product A. So think about the first Disney movie, and then you have a requirement specification. Okay, so that's an asset that you need to build your product. Then you have product A. Then you work on this project. The project went well, and then you start a new project, and the new project is product B. And like the new movie in Disney, like the new system that you need to develop within your company. Then what you do, I remember that I worked in this specific project in the past. Maybe let me take some requirement specification, let me take some assets because there are some similarities. I remember that I cloned it and I copied. So that's basically what the Disney creators did in the movies, and also most of the engineers do. So they remember that they work on previous project, they copy. Now they have a copy of maybe a requirement specification. It is very common in railway industry. So you start with that. You have a tender, invitation to tender. You take a previous specification and you basically copy it. But it's common really in every industry. And after you have copied, you start to implement in some changes. So you modify elements, you add elements, you remove elements. This sounds smooth, sounds very easy. Everybody understands it. It's probably logical and natural, but there is a big challenge with this. The challenge is that this is basically reused by accident. So you accidentally reuse something that was not meant originally to be reused. And then there are several problems that come with it. So the requirement may look similar, but the context of application is different. It's not exactly the same. So in the integration, in the testing, you may find issues. And then if you develop multiple of them, let's say 3 or 4 products in this way, then if you have a bug, if you have a defect in one of them, then you need to do a root case analysis in each system that you have been developed, because they've been developed separately, and you need to fix it in all of them. And sometimes you need to find different approaches to fix it. So these are just some of the disadvantages that come with clone and own. Now, another way to manage variation, to manage reuse, or to keep track of what is being reused in each specific system, especially when you have multiple systems of variation on those systems, is the use of this approach called applicability matrix. So you have like an Excel sheet, a spreadsheet with all the products on the right, on one of the axes, and you have all the features of the capability or the requirements that you are going to reuse, and you basically tick the box when it has been reused. Does it apply? Does not apply? Now, this can also be done. This can be done with requirements. You have a requirement database, let's say DOORS, very popular, all the requirement management tools, DOORS Classic, and you have like your requirements column, you have your product system columns, and you basically tick the box if the requirements apply or does not apply. Now, which is the problem with this approach? Again, in terms of management of the variability, it's very complicated, very common. It's very complex, and it's hard to manage when you start to have many variants, when you start to have complexity, interdependency across this feature capability that you see on the left. And if you apply to requirements, you end up writing much more requirements because you need to duplicate the requirements. Even if you change something small, you are going to rewrite again the requirement. So, and you need to retest it. So that's why it's quite of a intuitive approach, but at the same time can lead to inefficiency and high time consumed. Now, who is going to bridge? So basically, what Tim usually mentioned in his presentation and also in the book is this kind of trend that we see now. So we see that with the advent of new technology, AI integrated in systems, so the capability of our system increased more and more. So the system that we develop, that we produce, are very advanced. However, the engineering tools, as we see, that are used to develop those systems, like spreadsheets or clone and own methods, are not as advanced as the system that have been developed. So, and then there is a gap, as you can see. Who is going to bridge this gap? Well, the gap is bridged by the engineers, by the systems engineers, that every day needs to do their best in the organization in order to bridge this gap. But is there a better way to do that, right? So the idea is that we talk about motivation in the beginning and here, and is there a better way to do that? Well, let's have a look at what may be a better way. First of all, we talk about systems engineering. And system engineering, as the last 3 INCOSE visions mentioned, it's the future of system engineering is model-based. Well, the future of system engineering is model-based because models facilitate, if well understood, well used, spread in the organization, they avoid misunderstanding and facilitate collaboration. Now, this is very important because we mentioned about the capability of our system that become more complex and complex. And this is basically leading to project complexity, system complexity. You have multiple locations, you have work share, so new technologies, multiple variants being developed. And then as a system engineers, you need to deal with different disciplines that needs to be integrated together. So the software domain, the electrical domain, geometry, safety, security. And even if you take now the smartest brain in the INCOSE chapter in New Zealand, or in entire New Zealand, or in the organization you work with, so even the smartest brain will have challenges in grasping all this complexity and managing all this complexity. That's why many times the answer that I see is we bring more engineering brains to solve this gap. So remember the gaps that I showed you before? well, this gap is tried to be filled by more brains, by more engineers. But what happens if you don't put those engineers in the condition to work together? Well, instead of solving the problem, you may create more challenges. You can, because you create more perspectives, different ways of working. So that's why we said, okay, human brains so cannot keep with the complexity that we deal with alone by themselves, and also with the variation, the variability applied used in traditional engineering. And especially if now they have to develop variants of the same system, no? So the complexity increases exponentially. And then that's why, again, the question is, how can we deal with this increasing complexity and variability? This is part of the foundation, because we believe that the same way that systems engineering is model-based, or the future of systems engineering and the present of systems engineering is model-based, we also believe that since product line engineering, there's a discipline for reuse, we'll talk about it. It's an enabler, SE methodology, key SE methodology. Also, this should be model-based, as since system engineering will be model-based. Now, when to use which approach? I'm not saying that clone and own is always bad. So in most of the cases, it's bad. It is not optimal. But let's say you take two drivers, no? Complexity and variability. That's what we are dealing with. If you have low complexity, low variability, you build one or two variants of the same product, and the product is not that complex, maybe you can use clone and own without any big issue. Then, of course, once the complexity increase and the number of products increase, then, and maybe you still have an order of magnitude of 3, 4 products, not such a complex system, maybe it's a subsystem or a component, then you can deal with it with applicability matrix. But then that's probably where most of our systems that we produce, and if there is systems engineering in place, probably we are in this category where you have higher complexity and higher variability. So that's why you need model-based product line engineering. And these are somehow I would say the prerequisite, right? So if you have very large set of requirements and other assets, you want to reuse them, you have high variability and high complexity. You don't have just the requirement, but at least you have the models or the verification and validation items, the test cases. Then it's the case that you look at product line engineering, in particular model-based product line engineering. So why we talk about model-based product line engineering and not just product line engineering? Well, I mentioned before, the future of system engineering is model-based, so then accordingly, we have to promote product line engineering as a model-based discipline if you want to be in line with the INCOSE vision. But it's not only that. So this is really like, it's a win-win situation for model-based development, model-based system engineering, and product line engineering. First, because if you use models, I mentioned, you bring traceability, you bring consistency, you bring single source of truth, collaboration, and they help to manage the complexity. And but at the same time, product line engineering is a systematic reuse approach that help you enable the reuse of the models, and not just the models, but also the other assets like requirements, test cases. Now, it doesn't mean that if you do product line engineering, you just focus on the models. No, it means that you bring a model-centric approach in your development, but you still have the requirements, you will still have the test cases, but they are, let's say, related also to the models, because the model bring this type of consistency. Now, it's very hard to reuse models, especially if you have started MBSE or you have tried MBSE. First, you focus on getting it right, and then maybe you don't focus too much on the reusability. So the first model you have developed for the first project probably cannot be reused for the second project. And this, it's kind of a challenge because there is a high investment in MBSE, but it kind of, if you don't know how to reuse, then it will be hard to reuse those models. So that's why we said that product line engineering, if you bring systematic reuse from the beginning, you can facilitate the reuse of the models. You can easy and justify the return of investment. And most importantly, you have a single source of variability. It means that you can have one source of variability, and you can control the variability in your assets in one place, from one place. Now, last slide regarding the foundation, then I will hand over to Tim. We have here the MBPLE foundation in the standard. So there are 2 standards, and the main standard is the 26550 from 2015, and the standards was laid the foundation of product line engineering, but was still mainly software oriented. And then there was no specific definition of features. There was not a specific definition of the product line engineering approach. And that's why came in 2021 new standard 26580. That's basically introduced the concept of features, introduced the concept of models, and most importantly, introduced the concept of the PLE configurator, PLE factory, and facilitate the understanding of this discipline. That's why you need to use usually both standards. But if you want to start now, the 26580 could be a good starting point. And of course, once you master it, or at least you understood the standard, then you can also look at the first standard and try to understand what changes and also what you can pick from the first standard. Now, I will hand over to Tim, and Tim will show us the implementation, and maybe we'll talk a little bit about the adoption. Tim, please.
Yeah. Yes. Yeah. Thank you, Marco. So you have the control of the slides. Huh? Yeah, let's talk about the MBPLE implementation. And first, let's have a look on the MBPLE paradigm. So there are 4 steps in the MBPLE paradigm, and the first one is defining the feature models. And the feature model defines the variability of the product line. So it's the single source of the variability. And in the feature model, you have typically these feature trees. I will show you an example shortly. And a feature defines one characteristic of a product that has some kind of variability. So typical examples are in a car, different kinds of engines, different kinds of seats, different kinds of doors, things like that. So that's the feature tree in the feature model. And another part are the feature configurations. A feature configuration is a valid set of features. Now, you cannot combine any kind of feature. So if you have a specific engine, then you are only allowed to select this and that air conditioning system or something like that. So there are rules between features. If you select this one, then it's not allowed to select the other one, or you must select another one. So in the feature model, we have the feature trees with the rules between the features and the feature configurations, so valid sets of features for a specific product. Then the next step is that that's the largest step, I would say, that's define the so-called shared assets supersets. And a shared asset is a digital engineering artifact of any kind. So it's your SysML model or SysML model element, but it's also your CAD model, simulation model, source code, and also Word and Excel and everything. So everything you need to specify your products. And it's about all your products, so all the products of the product line. So the models in the shared asset supersets are also often called the 150% models because it's more than 100% in the model. So these are the shared asset supersets, and they are full of variations and variants. Now, if we have a CAD model, for example, then we specify a mechanical component which can vary because depending on which feature we select, we use this size or that size of the component, things like that. So we will also see examples of that later, but not in CAD. I'm not a CAD specialist in SysML. Yeah, then the next step is, well, we select one of those feature configurations that we defined in the feature model. So we select one configuration for a specific product. And then finally, in the fourth step, we can derive product models for this specific product from the shared asset supersets. And this can be at least partly automatically. We have the shared asset supersets models. We know the features and we know the relationships between them. And then a feature configurator can automatically derive a product model from the shared asset supersets. We will also see a very simple example of that. So these are the four main steps, and it's not, well, it's a logical order, but of course in the project it's not exactly a waterfall process. No? It's only the logical order. So here we see an example of a feature model. This is not SysML. It's a feature-specific notation. In this case, I used the feature modeling tool Feature IDE, which is an open source tool. But there are other ones from Marco's company, from PTC, the Pure Variance tool, and there's also Gears from Big Lever, and some other tool vendors also have feature modeling tools. And all these tools provide this feature tree notation. It's 80% the same, I would say, and then in each tool there are some deviations between them. So at the top you see the root element, and then here it's about a drone. The drone have different mission kinds, mission times. We can select, oh, it has a payload or not, and then the payload size, and so forth. Next slide. Yeah, and here's an example of a shared asset superset model. So now we are not in the feature model, we are in the shared asset supersets, and in this example, it's SysML. In particular, it's SysML v2. So if you're not familiar with SysML v2, but with SysML v1, what is called here part is in SysML v1 the block or the part property. So we have a drone system at the top, and the drone system consists of drone docks, so landing places for charging and just parking for the drones. We have the drones itself, and we have a control station, and our drones are defined by this part definition drone that you see here in the middle. And a single drone is defined by, for example, if you go further down, it has a battery, and the battery can be a standard battery or a power battery. So here we have a variation, and the keyword variation and variant, these are keywords from the SysML v2 language. So SysML v1, the previous SysML version, has no explicit support for variability modeling, and in SysML v2, it's part of the language, it's part of the standard. It's very simple in the language, but it's an anchor point for the variability topic in the standard. So the variation is the point where you have to make a decision, and the variants are your decision options. So the battery here is a variation point. So we must decide, do we take the variant standard battery or power battery? And the same on the left side. Now we have 4 to 8 engines. This is the variation, and the variants are 4, 6, or 8 engines. Or on the right side, we have a payload attachment, and we must decide for small payload attachments or large payload attachments. In this example, it's about parts. So the breakdown structure, the physical breakdown structure of our system. In SysML v2, the variation and variant construct works for any primary engineering element. So you can do the same for requirements, but also for behavior, for states, actions. So yeah, ports, interfaces, everything is built in SysML v2. Yeah, the next slide. Yeah, now we select a feature configuration, and feature configurations, as said previously, are a valid set of selected features for exactly one product. They are often represented in a matrix. So the features are then the rows, and the configurations are the columns, and then you select the features. Here's an example of a domain-specific extension of SysML v2. SysML v2 does not support the modeling of features. It supports the modeling of variants and variations, and that's different. It's very often mixed up. Features and variations are two different things. The features are in the feature model, and the variations are in the shared asset supersets. So completely two different things, but often mixed up, even if experts are sitting together, they mix these concepts up. So it's so SysMLv2 does not support features, but you can introduce new concepts into the language SysMLv2 by a language extension mechanism. It's the same in SysMLv1. If you're familiar with that, then there we have the stereotypes and the profiles, and in SysMLv2 it's a different concept. And here you see an example of feature configuration. So at the top, it's the delivery drone is our configuration. So for a specific product, and we select the X power battery, a special power charging strategy, and so forth. And below is an observation drone with other selected features. Yeah, next slide. And now the last step. So we select a feature configuration. It's a delivery drone, and now we can derive a product model. And here again, as an example, it's SysMLv2, but we do the same for all the other engineering artifacts. So for CAD models, Word, and Excel, and so forth. And then it depends on the capability of those engineering languages and tools, how to describe the variations and variants and so on. So at the top, you see the delivery drone system X42. That's our concrete product. It's specialized from the drone system on the left side, which represents the whole product line. And then you see some very special notation. That's SysMLv2. But you see at the bottom that we have engines is now 6 engines. The battery is now the power battery. And at the bottom, the payload attachment is now the large payload attachment. So that's part of the language, and now specifies one single product. In this example, in SysMLv2, our single product model has still a connection to the product line. There's also the approach that it's transformed from the shared asset model, so it's then independent of the product line model. Yeah, and finally, nowadays it's not possible to make a presentation without AI. So here's the AI part of our talk. Of course, AI is extremely important. It's one of the biggest changes in the world, I would say, and of course also in engineering and also in systems engineering. And in systems engineering, we have 2 streams. It's called SE for AI and AI for SE. So the left part is how do we do systems engineering for AI-based systems? But the most focus is currently on the right side. So AI for systems engineering. So using AI as an assistant for systems engineering. And you can classify two parts of it. One is use AI as a domain expert. So if you are a drone manufacturer, you can ask the AI, do you have a good idea how we can do this or that? More important is on the right side, AI as an MBSE or more general MBE expert. So it can support you with the methodology and simple things like in a modeling tool, in a system modeling tool, you have the ideas. So I know the breakdown structure contains this, and that part. Model it for me. And then the AI assistant do all the clicking and not you. So it's very effective to use AI, and you can also already use this today. So there are already plugins available for SysMLv1, and we will see many new stuff there for SysMLv2. Yeah, that's about that. And with that, I hand over back to Marco.
Team, maybe we can share the adoption part. So I will just present the business case. So we talk about adoption. Maybe team, you can talk a bit more about the framework and the quadrants, the 4 quadrants, if it's okay for you.
Yeah.
Today we make a swap on the presentation. So usually we are different order. So that's why we are making a test. So adoption, we have now the motivation. I think you should have at least a little bit of motivation. You should have a bit of understanding of what reuse is, what product line engineering is, the 4 steps that Tim presented. And then, as Tim mentioned, the step we focus on models, but you can do it for CAD and other type of assets, requirement test cases. But of course, at the end of the day, everything goes back to the money, right? To the investment, to the return of investment. And basically, to make it very short, This is according to what we show in the book, according to the cases that we have and the experience that we have, and that if you develop more than 2 products, or at least 3 products, and better if more than 3 products, as you can see, you will start to see the return of investment. In fact, if you develop the same 3 products without model-based product line engineering, you will see that the curve, it will be steeper, and then at a certain point, at the 3rd product, you have the return of investment. So that starts, so the break-even point. And after the 3rd product, usually you are better off with the product line engineering approach, the model-based product line engineering approach. Now, this also shows that you don't need to invest everything at first, at the beginning, in the off cycle, out of the cycle. So you can also share the investment of your product line, of the parts that you reuse across the different projects. It's maybe not as straightforward as it looks like, but it definitely helps organization to implement PLE instead of having a big budget exposed and exploding already at the beginning of the project. And in general, this is just another view of it, that if you take a fixed number of products, let's say 4 or 5, and you calculate the accumulated non-recurring cost for this given number of products over the period, you can see what happens if you use just a client-owned approach. So you will have much more cost because you don't have reuse and sharing. If you just use a modeling and simulation MBSE approach, you may manage better the complexity. You may have some reusability, but still you end up having high cost. But if you are able not to reuse those models, those assets with the MBPLE approach, then you can again be better off. Of course, this does not apply to one product. It's clear, right? So 1 product, 2 products are still more expensive than developing them with MBPLE approach, because they have the lead penalty of being the first products to be developed, including assets to be reused. And maybe, Tim, we make a test. So I hand over to you, the quadrant.
Yes. So the MBPLE, sorry, adoption quadrant, it shows a coordinate system that you have seen before when Marco explained the clone and own and the matrix and the MBPLE approaches. So we have the complexity and the vertical axis and the degree of variability on the horizontal axis. And here you can you locate yourself and see or plan your next steps. So in the lower left corner, we have projects that have a very low degree of complexity and not so much variability, and they can be document-based or do document-based systems engineering. Well, actually, many projects are in this corner, but they have a high level of complexity and also a high level of variability. That's for them then the issue that we also explained before. And if you would like to master your complexity issue, a typical step is then to move to model-based. That's on the top. So you go from document-based systems engineering to model-based systems engineering, which is, well, as INCOSE says, it's the norm for systems engineering. So if you do systems engineering, it's model-based. That's you cannot do it otherwise. So that does not make much sense nowadays. So that's this path. And then to the right side is the PLE. So if you have a high degree of variability, then it's a good advice to use a PLE approach. But if at the same time your complexity is not very high, then you can do the traditional PE, let's call it like that. So you do product line engineering and probably document-based. But if you have both, now you have the high degree of complexity and the high degree of variability. And I think for most projects, that's the case. Then you are in the model-based product line engineering area on the upper right corner. And you see there are different paths from lower left to upper right. So it depends on the urgency of your issues. So if complexity is your main issue and you're in the lower left corner, that probably your first step is move to model-based systems engineering and then to MBPLE. And if the variability is your primary issue, then you go the other way. But it's not a good advice, I would say, to go from lower left to upper right, because model-based product line engineering that's tough. And if you do it in one big step, it's better to do it at least in 2 small steps. Yeah, sorry, next slide. So then in the book, we also describe the MBPLE framework. So currently there's a high focus on SysML v2 in particular. And of course, it's much more than SysML. Now, systems engineering is much more than SysML. MBSE is much more than SysML. It's only the language. And here, the language SysML is, I would say, in the bubble of the methods. We have the language, and we must describe how to use the language, SysML, but also other modeling languages. And on the left side is the processes, like the 4th step, the MBPLE paradigm is in there, and other processes. We need an information model, so we must specify our concepts. Now, what is a feature? What are the attributes of our feature in our project? Now, how do we link the features to the shared assets, things like that. And then, of course, we need the tools. And that's the challenge here. We need not a single tool, we need a tool chain, so the tools are connected. We need a PLE tool, and the PLE tool needs connections to all our shared assets models, so to all our engineering tools, SysML tools, CAD tools, and so forth. And we should not forget there's an organization behind that. So it's not only about methods and tools, there are people that use the method and tools, and the people are in an organization, and that also must fit together. Maybe you know the Conway's law that says that the organization structure is aligned with the communication, with the product architecture. And it's a law, no? And if there's no alignment between the architecture of your product or product line and the organization, you also get issues. I think you can better explain that, Marco,
Yes,
because
yes.
you're the chair of the PLE group.
Yeah. Yes. So thank you, team. Now, for those that are not familiar to the topic or are familiar, would like to understand more about product line engineering. Of course, we have the book, but maybe since you're already INCOSE member, the easiest step is to go to the INCOSE page and register, subscribe to the PLE working group. So I am chair of the PLE working group together with Roland Darbin from General Dynamics Mission Systems. And we have actually a very successful working group, and we saw a growth of 90% in members in 1 year. And this is because of the relevance of the topic and because of the several initiative activities that we support with the working group. So please have a look at it if you are interested. It's a very nice way to transition into a PLE approach to start learning. And that's basically what I wanted to say. And now, as we mentioned, we have, before heading to the conclusions, just want to mention maybe a couple of cases, because we said, okay, there is also a practical approach, and it's a practical approach, and it needs a practical application, and we want to see companies that did it. So first is Airbus, and it's part of the book. I just picked 2 of the 5 because of time. And Airbus, the key concept here is that the variability within an aircraft, it's everywhere. And not just within the aircraft, but also across the final assembly lines. Imagine Airbus has different assembly lines in different places in the world, and each assembly line somehow have variabilities. So the aircraft, the product lines, the product families that develop have variabilities. And then the services, the way MRO services and other type of services are done, are executed, also have variability. So when you develop a system with such variability that comes from different places, you need the place to steer, to control the variability. And that's the feature model, like Tim explained. And then, of course, this variability reflected also in the hierarchies of the system. So you have variability at the aircraft level, at the cabin level, at the lavatory level, the galley level, and up to the lowest level of your items. And then that's why you need to see how the different variability cascades from one level to another. And then you have architecture-wise different variability, different weight to implement. Maybe you have same functions but different allocation of those functions. You have different operations of the aircraft, and you can implement the operation in different ways. So you have also, and then finally, different suppliers, different physical implementation, different interfaces, and last but not least, when you develop an aircraft, usually it takes years, and you have variability along the life cycle. So at the first stage, you don't have all the variability information. You are just high-level variability drivers, and then the more you go into the details, the more you enrich your models, your artifacts. So that's why you need an incremental approach. So there is a paper also about it, the 4 dimensions of variability at Airbus and how Airbus use them to apply MBPLE. If you want to know more about that, but also there is a chapter of the book talking about the specific details of the Airbus case. This is just one of the aspects, that the variability is everywhere, and they need to manage it. Now, the second cases that we have is Thales, and it's basically very simply Thales. This is the ground master radars. The ground master radars, usually before applying PLE, they are composed of over 40 large software, so megatronics components, and with a lot of variability, and they had very high difficulties in testing and maintaining all of that. So they switched already like 15, 16 years ago to a PLE approach and then MBPLE approach. Remember what Tim shows, the patterns. And now with just less than 70 features, they're able to control 3,000 parameters, not just 3,000 parameters, but also values, variability in values associated to these parameters. So let's say that each parameter has 3 possibility values, or you end up to 9,000 parameters. And then imagine that these 9,000 parameters are in your requirement specification, your test case specification, DNV models, and imagine if you need to update a couple of them, how long it will take you to go across all the documented, all the assets, right? So we bring this automation. You just update the parameters once in the single place in the variability. You pick the value for your parameters, and then you cascade the selection across all the variants of the assets. And this way, they could reduce an update of parameters from 120 hours to 4 hours. So there's really a big return of investment if you do this properly. This just was just an example, and before we, let's say, had to, maybe we'll have some questions from the audience team. Maybe you can draw some conclusions.
Yes. Yeah. So the first key takeaway is that the ISO standard 26580 is the guiding standard for model-based product line engineering, and MBPLE leverages features as the single source of variability, like the conductor guiding an orchestra. That's why we have this cover page on our book. The feature model acts as the score and orchestrating variability and commonality into a symphony. And adapting a model-based approach ensures then an optimized, cohesive, and precise product development. Secondly, the MBPLE factory is something that is achievable today. So the necessary standards, languages, and methods already exist and can be deployed with limited shared assets initially. And scaling should be aligned with organizational maturity and prioritize engineering artifacts, enabling teams then to efficiently manage complexity and variability at the speed relevant to your business needs. And lastly, tools play a crucial role in enabling the full digital continuity. If you have the best methods and the best language, does not work without the tools. And currently, tools often fall short of providing complete end-to-end support. So it's also a task for the tool vendors to close the gap there. And there's a lot of stuff going on in this area. So this is, I think, one of the hot spots in engineering and digital engineering today. Yeah, with that, we are at the end of our presentation. So thank you very much. And maybe we have some time for a few questions, if there are any. And we hand over to Jess, or Jess, are you? Yeah.
Sorry. How
Hey.
long was I talking on mute before I realized I was talking on mute? You think by, with this much practice, we'd all have gotten over that by now. We do have some folks here in the group, but I haven't. So go ahead if you are keen. You can either hop off mute or put your hand up in Zoom, and we'll throw over to you. Luke Fisher, go ahead.
Hello, thanks for the presentation. So my question's around, so how do you manage risks associated with reuse, in particular around emergent behavior? So I mean, you mentioned the sort of or aviation sort of example. You take an unnamed model of aircraft, you copy it, you paste it, you increase the size of the engines, tweak the software a bit, but all of a sudden you've introduced a whole bunch of safety related risk. So how do you manage risks in particular associated with emergent behavior when it comes to reuse of these sorts of models?
Yeah, maybe Tim, I start, and if you want to continue. So from that's exactly the very good question, because it's exactly the point when we mention the clone and own approach. That's what we don't want to do, because if, as I mentioned before, if you develop an aircraft, a specific model of the aircraft or a subsystem within the aircraft, and then you want to reuse it, let's say after this first model is out, or along the development of the first model, but you have not spent the time to assess and analyze the risk, the advantage, the disadvantage of reusing it, the interdependency of the subsystem in a new context of operation, for example, right? That's exactly where the problem comes, because it may work for that specific purpose, for those specific requirements, and you have been testing it for that. But then for a second model that is reusing the asset that were not intended to be used in that second model, but you decided to do it by accident. That's exactly the challenge of such a clone and own approach, that we say may look simple, it may look logic, but it has a lot of implications, because we are systems engineers, so we know that a system is not just the system itself, but also the context in which operates, the part is made, and all of this also is reflecting the assets that you use. And it doesn't work just always like copy and paste. And basically, if you have a systematic reuse approach, so you will take the time, and from the beginning, you will think about how we have to reuse this in different contexts, in this scenario, for different requirements. And that will help you better. That will help you better to manage the risk.
So at what point in the process does that happen?
Well, so first you need to decide, am I going with a product line approach? Okay, so when you decide to go with a product line approach, it's exactly this. Okay, I'm not just managing now these as variants, independent variants that don't share anything between them, but I'm going with like a product line. And then, so basically it's the beginning of your development. So you will decide if it's a greenfield approach that you are going with a product line approach. So that's exactly the moment. There are other ways of doing it. So you can transform a legacy into a product line. But then, as I said, a careful analysis needs to be made in that specific case, because you are transforming something that was not supposed to be reused originally. Okay, so that's why in that case a bit more complicated, but companies do that.
Yeah. So are there any other sort of examples of where use of product line, the product line approach would be inappropriate?
Inappropriate. I'm thinking. I may not think any of. So basically, if you build, as I mentioned at the beginning, if you build a commodity system that's very simple, and you have a mass standardized product, then there's no sense in building a product line, because it's already, let's say, the same product, standardized, that with little variability. and only the price is the main differentiator of your product. I may think of like a pen, maybe, really like commodities, this or materials, raw materials. So in this processed materials, you take the raw material, you process it. So this type of product maybe don't make so much sense. But otherwise, all engineered product, even services, could be developed as a product line.
Cool. Thank you very much. I'll
thank you for your question, Luke. Team,
no worries. I'll hand over to Karina, who has a hand up.
Yeah.
Hi,
thanks.
Karina.
Yeah, thank you. This is kind of related. So if you are, for example, at a small startup that is dealing with, that is sort of hyper-focused on getting a single product off the ground, what steps should be done proactively to think about, hey, in the future, we might want to develop a product line, but no one's thinking about that at this point. What should be done sort of proactively before even the decision point of we're going to develop other things is made?
Team, maybe wanna...
Yes. So, well, that's a good question, of course. And I don't think that such a startup should start with MBPLE from the early beginning. So the primary focus is to get one product on the market, and has the highest priority. And and you can move a standard product development to an MBPLE approach step by step. So that's possible, and that's then the outlook for the startup. And of course, you can prepare the step from the early beginning. So if we speak of a SysML model, for example, because that's my expertise, you can already create your model in a sense that it's already prepared to be moved to the product line. So you separate different concerns. You already create libraries and things like that can already be done from the early beginning. But you can also do this later. So but it depends on the priority of the startup. But I think it's important. It's also to Luke's question, is that there's not one MBPLE. No? An MBPLE must not be a big thing. It can be a big thing for a project, but you can also apply a very pragmatic, straightforward, simple MBPLE approach. That's also possible. Marco, do you have something to add?
No, I think I agree with you. And maybe as a point that's so what our focus were mainly on medium and large organizations, because where we see that they can really benefit from it. Now, startups, of course, you can, but first you need to return on the investment with the first product. You need to show that you have a market value. You need to show to your investors that you can survive and along the years. So if you have other priorities, maybe definitely product line can be an enabler. But remember, for the first product, you still have a relative high investment, first, second product. So maybe if you're a startup, you will not start immediately with a product line, but as a team mentioned, you can have the thinking of reuse from day one. I don't know if
that's great. That's really great. And hearing you talk about, I don't recall whether it was you, Marco, or whether it was Tim, who said that if you think of your services as products, and I work for a consultancy, we have a wide array of services that we offer. Our service offerings are also relatively, there is a degree of embellishment and customization and new application for new client, new context. But I'm intrigued thinking about the possibility of building a model-based product line for services, because I think I'm starting to see how that could bring benefit. And And you've got systems engineering approaches influencing how New Zealand businesses do business, and then goodness for everybody. We have just hit the 1/4 past the hour. And so we'll probably tie it up right there. I think, if I'm not mistaken, your book is published through Wiley. Is that right?
Yes, correct.
Right.
Wiley, which means INCOSE members are entitled to, I think it's a 20% publisher discount.
Well, it's not okay. We don't have such arrangement, unfortunately, but we still have 20% discount if
Okay.
you book directly with the daily, not through the website. So we'll
Okay.
give you the contact of the person, and
Fabulous.
and that you can really get there the 20% discount. Okay, so we have this
Perfect.
agreement so that we overcome this. Maybe just a few one comment on the services. There is a paper of Guillermo that wrote the book with us when he was at Thales, and he explained how you can apply this to railway services. Okay, and in general, I end up some years ago in a company, a bank, that wanted to use product line engineering for mortgage, because depending on the clients, they need to give different type of services, different type of documentation. So you may think about using these for services as well.
So there's some product does not just mean widget anymore. Excellent. Well, I'm going to grab the screen share back and just finish up with 1 or 2 more final comments. And I think I've clicked share enough times that should be coming through. So thank you everybody for coming along to this, our May meetup. We have another one scheduled for lunchtime on 26 June. The speaker and topic are still to be confirmed, but we're already looking forward into July and even into August. So as soon as we've got details and a lineup, we will be sure to share those with you. And as always, thank you again for, oh, this slide is old. I need to fix that. Thank you all for coming along to another INCOSE New Zealand event. I need to change the INCOSE New Zealand points of contact to reflect our current our current committee. This is where one time where I should have a product line for my INCOSE meetup slides. With some variables that I can tweak in this way. The best way to make sure that you keep you're in the loop for INCOSE New Zealand events is the mailing list and following us on LinkedIn. So thank you all for your time and attention, everybody. We will call it there.
Thank you. Bye-bye.
Okay, thank you.
Thank
And
you very
bye-bye.
much.
Bye.
Thank you. Bye.
Thank you.
Awesome.
Bye-bye.
Bye.